Hello guys, this is the second part of homework, chapter 6, homework number 2. This is the second part. I did the first part earlier. This is a little bit easier, I feel, as though once you get the hang of it, but just gotta make sure you get the formula, or writing this down correctly, not really a formula, but just make sure you follow the steps correctly. So, take your time, have a pen and paper, and do this problem out with me. So, problem exercise 6.53 states, hydrazines, I'm not exactly sure how to pronounce that, is a fuel used by some spacecraft. It is normally oxidized by N2O4 according to the equation. N2H4 liquid plus N2O4 gas equals 2N2O gas plus 2H2O gas. So what are we even doing in this formula, in this problem? Well, you're trying to solve for delta H. When it all comes to, you're trying to solve for delta H, right? So, this is what the formula is going to look like. You're going to take the products, which we know the product as this, subtracted from the reactants. So, simple. We have products minus the reactants. Alright, so, okay, what does that mean? What do we find the values for? How do we find the values for? So you're going to have to find the enthalpy, or the delta H value, for each and every single one of these. The N2H4, the N2O4, N2O, and the H2O. Now, you don't have to do any complex things. That is given to you in the back of your book. Forget exactly what the page is. Well, actually, mine starts at A7 and it continues for multiple pages. So if I were you guys, I would just take it out, staple them all, because they're going to keep flipping back and forth to these for the next few classes coming up. Anyways, back to this. So we're going to put the products subtracted from the reactants. So let's do that. We have the products, which is what? We have, I'm going to put brackets, parentheses, 2N2O gas plus 2H2O, which is also a gas. I should probably write that in. Whoops, gas, bracket. Now you notice that is the products. Now that is subtracted from the reactants, which is parenthesis N2H4 liquid plus N2O4 gas. I believe that says. Alright. Perfect. So now what you do is you look into the back of your book and you go to find the delta H values for it. Well, I've already done that, so I'm just going to label them right now. For, let's see, H2O, delta, what's the right, delta H's. So, for H2O, I got something that was minus 241.8 for, let's see, I'm just going to make my font a little bit thinner right now. H2O, then we have N2O gas equals 81.6. We have N2H4, which equals 50.6. Then we have, lastly, N2O4, which equals 9.16. Alright guys, now make sure you are very careful. If you notice right here, I have gas, gas, liquid, gas. If you have H2O gas, it's going to have a different delta H value than an H2O solid. So be extremely careful on which ones you look in the chart and which ones you perform calculations with. So now, not too complicated, it's pretty easy actually. Now we just plug in the values into what we know. So we have 2 multiplied by N2O gas. Well, let's look what I found. I got 81.6. So 2 times 81. I apologize, I'm going to make this even more clear. We have bracket. No, we have, inside that we have 2 multiplied by, what did we say? We agreed it was 81.16. n parenthesis plus 2 multiplied by minus 241.8 parenthesis. Now, before I move on to finish this, now if it's a negative value, don't try to do any algebra tricks. Just plug it identical into the formula. And if you're plugging this into your calculator, make sure you have double parentheses. We have a parenthesis right here. Then we have another one right here. Then it will close. Plus another one right here. Then it will close. Then the end parenthesis. And just plug that exactly into your calculator, so there's no margin of error. Alright, let's finish this off. N2H4 is a coefficient of 1 in front of it, so it's just going to be 50.6 plus 9.16. So I want you guys to go ahead and plug that in. I got a value of negative 380.2 kilojoules. That should be correct. Hello everybody, we have another problem, exercise 6.54. Propane burns according to the balance equation C3H8 gas plus 5O2 gas, 3CO2 gas plus 4H2O gas. Now before I even go any further into this, I'm just going to write the given values of the delta H's instead of having us to go solve for them in the beginning, having some pausing or whatever. So we're going to, right here, I'm going to write for C3H8, I found minus 103.85. For O2, it's 0. We lucked out on that one. CO2, minus 393.5. H2O, minus 241.8. So we lucked out here. Lucked out with this one. The O2 being 0 makes the calculations a little bit simpler. Now again, these values that I've given to you right here, these I did not calculate. I simply went in the back of my book and just looked at them and wrote them down here. Those do not need to be calculated. On a test, Professor Cross would give you a handout that had all these values, and you would simply have to flip through the handout and find the values. Enough of me talking, let's get back to this problem. Now, if you remember from the previous one, it's going to be the same setup. It's going to be products subtracted from reactants, right? Perfect. So, let's just do that out. We have 3CO2 gas plus 4H2O gas is the product, so that's going to come first now. We have 4H2O gas. Forgive me for my handwriting, guys. This is very tough with this stylus. I don't have an expensive one. Then we have products over reactants plus 3CO2 gas minus C3H8 gas plus 5O2 gas. Alright, so we have that done out. Now, if you guys, I just want to make sure you guys emphasize on this. This value right here and here, that's the product and the reactants. That plus sign, that stays positive and that stays positive. That doesn't get changed because right here, it's positive and positive. Those don't get changed. The only thing that gets changed, like that negative value only comes in because we're doing products subtracted from reactants. Oops, that wasn't supposed to do that. Now let's go on with this. We're told that 4H2O gas was negative 241.8, so why don't we just go ahead and plug that in. Now we're going to multiply by what value? 4. So we have parenthesis 4 multiplied by negative 241.8 plus the value of 3 multiplied CO2, which I told you was negative 393.5. Close bracket. That's the products. Let me just emphasize that real quick. Alright, now let's continue with this. Subtracted from the reactants, right? Reactants, now remember, we have C3H8, which is only 1, so we're going to do blue. We're going to do 1 multiplied by, you don't have to write that 1, it's up to you. Depends how you like your algebra. 8, 5, and like I said earlier, we were locked out with algebra because of that 0 plus 0. Oops. Plus 0. Close parenthesis, close bracket. So when you guys did this out, I got a value of roughly, let me just look for it again. I got a value of 2, negative 2, 4, 3. Oh. I got a value of, negative 2, 0, 4, 3.85. Now, what would this value be? What would the units be? Kilojoules. We can never forget that. And this is your answer. Alright, we're going to do one more, and that should be it for Hess's Laws. That should be it for Chapter 6, homework number 2.